Hi, Ed Veronder here from OptiSurface, and in this video I'm going to demonstrate to you how we can design drain channels using exclusion subzones and breaklines. So the exclusion subzone is the pink subzone here called D2 or drain 2, and the breakline is the black line. So what we are trying to do in this field is to drain everything to the northeast corner. So we have a ridge subzone here to prevent water from draining out here. And yeah, this is a ponding area actually, and this is shown here. And on the proposed topography, what we are trying to do is take the water here and let it drain to the north instead of to the south. That's why we have the ridge subzone here. And yeah, if we let OptiSurface run without the exclusion subzone, this is what it will actually look like. So water here drains there, but it's cutting too broadly, too wide. So we can narrow it down using drain channels like this. And what you want to do is first is take on the grid points, because you need to make sure the exclusion subzone covers one row of points like this. This covers one row of points nicely. And to add a subzone, you can either right click, add new subzone, new design zone, subzone, or use this toolbar, draw polygon zone, and hit OK. So I have drawn that here, and I will just turn this on as an exclusion subzone. Okay. And when I run this, I will recalculate the landform design, and now this will be an exclusion subzone. So what it does is basically tells OptiSurface that this area is not included in the design and water can actually drain into it. So let me show you that. So I will pause this and get back to you when the landform design calculation is finished. Landform design calculation just finished, and you can see here that there are no grid points inside there. There is a surface triangulated in between, but that's because it's triangulated in between these 2 points. As you can see here, when you set the triangles, yeah, you can see the triangles here. This is a triangle, so it is triangulating across that exclusion subzone. Yeah, and water can actually exit into the exclusion subzone as shown in this drainage analysis. So you can see here, water exits into that. So what the exclusion subzone does is it actually acts like a boundary inside the field, so water can exit through that. But as you can see in the surface, we need to add something in to actually let water drain in there. So that's where the break lines come in. Okay, what we have to do next is add in the break lines to actually design the drain channel. So what I'd like to do is look for the point where I can start. This is the lowest point. Basically, you want to select a point, the lowest point here. And what can assist that is you can right click the properties, proposed topography properties, and then turn on the elevation labels. So we'll see which point is the lowest. So that will actually be these 3 points here, should be the lowest. So 633, 703, 671, 669. So this is the lowest point. So we can use that as the reference point. So let's do that. You can add a break line using right click, propose topography, add break line, or use this draw straight break line toolbar. So let's use that. And what I like to do is start here, first click, and then second click, and then end at the other point at the exit. So that's our break line, and you can actually turn this off so the surface triangulates without a break line. So we can see the profile here. So this is the proposed topography. This straight line is our break line, and the red one is the existing topography. So this point is that starting here, and this is the elbow. And what I like to do is edit the breakline table to make sure everything falls where I want it. So in this case, I want it to fall to this side. So I'm adjusting the slopes. When you adjust the slopes, the elevation will automatically be calculated by OptiSurface, so it will be adjusted. So when I hit 0.05% slope, the elevation will change. There we go. And then do the same here. Then hit OK. So that's good. But I don't actually want this point. I just use this as a reference, so I know from this point going here is 0.05. So we can delete that point. So all we have is this line here. Actually, when you see this here, it's actually not exiting properly because this is a bit lower than the surface. So what we have to do is actually lengthen this up. So here, edit break line, and then maybe go a bit further, maybe up to here. Let's see. Yeah, I think we'll only need to go up to here. So we'll add a point here. So right click, add break line point. So not quite there, but that will do. And then delete this point, right click, delete. Then stop editing. So now we have the center line for our drain channel. What we have to do next is basically just batter it out. So right click, batter. What we are trying to do is shoot to the proposed surface. So click that, and we want it to shoot in both left and right. This is our center line. This is what we drew. So that's it. So we can just select left if we only want this, but in this case we both want it on both sides. And yeah, the slopes here, if you are, this side slope here is representing this line, but if your center line is actually higher than the proposed surface, it will actually batter down the surface, and this is the slope that represents that then. The flat width is basically this line will offset both sides and then shoot the batters. So we want a flat width of 5, and the calculation spacing along the center line, we can use 5 for that. And max distance from the center, it will shoot to make the batters is 100 meters. That's okay. We need to take this on, triangulate without break lines for the calculations. So the surface first is triangulated between these 2 points, and then the batters will be shot up. Update related offset and batter lines if they exist. If you are editing this, if you want to redo it, you can take this on and it will automatically update the old breakline. And delete points inside the batters. Yes, we want that, so the grid points won't mess up the triangulation of the drain channel. And yeah, the surface will do its thing, and then yeah, once we zoom in that area, yep, that's good. We can now triangulate it. Hit this, triangulate proposed with the break lines, and we have the drain channel. Let's turn this off, the design zone, so you can see it properly. So water can now drain here, and you can see that in the profiles. Let's see the profile here. Add some profile line here. Let's stick that on so you can see the profile. There we go, I have that already there. But this one, it doesn't really look good because the profile triangulation is too coarse. We have to adjust that. The sampling spacing to, let's say, even half a meter. Yeah, that's better. So yeah, as you can see here, this is the surface, proposed surface, and then this is basically the center line. So the center line was offset by 2.5 each side to create a 5-meter base, and then the batters here shoot up back to the proposed surface by 10%. Yeah. So yeah, that's it basically for the drain. But when you look in the cut fill map, it's actually not there. So what you have to do is recalculate the cut fill map to update this area here. So recalculate, and we recommend following the grid bearing of the design. So I think we did use 0 here. Yeah. And recalculate 0, 5 should be good. You can either rebalance this to balance the earthworks, so it will lift or lower the surface depending on what it needs to satisfy this cut fill ratio, which is 1.2. So we can use that. Hit OK and go back there. So you can see here the cut is now much more thinner than what we had before. So yeah, and water should be able to exit in there. What I'd like to do is turn this into a valley subzone only for the drainage analysis for the proposed. So you can change that to a valley subzone. Hit OK and calculate the proposed drainage analysis. Hit OK. And yeah, that should be good. So you can see water flows nicely to exit there to the lowest spot. And yeah, just return that. So we just turned this to a valley subzone, so the OptiSurface can calculate a flow path in that area, but we didn't use that for the landform design, just for the drainage analysis. It's still an exclusion subzone when we did the landform design. So yeah, that's it. Hope that helps. Thanks.